And finally, we have the second video, or the second part to section 2.6. It's a couple of graphs and then we will be done. Number 9 says y equals -3 sine of 2x plus pi over 2. So we have sine. I can see that the amplitude is 3, but this negative is going to reflect it over the x-axis. So I know I'm going to reflect over the x-axis. The amplitude is going to be 3. Sine means I start at 0, 0. I'm going to have some sort of a period change, and I'm also going to have some sort of a phase shift. So I know x-axis, the amplitude is the absolute value of -3 or 3. The period, since we're talking sine, is 2 pi over 2, which simplifies to pi. And the phase shift will be -pi over 2 over 2, which equals -pi over 4. So we're going to shift pi over 4 to the right. Something that seems a little bizarre, but we're going to shift pi over 4 to the right. So give myself just a little bit more room. I know the amplitude is going to affect my y-axis, so we'll go up 3 and down 3. The period is pi, so I should be able to make 4 marks here to be pi at the end. And my phase shift is pi over 4 to the right. Well, if we look at this carefully, this is pi over 2, and pi over 4 is each one of these marks represents pi over 4. So moving to the right, because it's the opposite of what we may think, and it's sine, so that means normally we would start right here, but we're shifting it pi over 4 to the right, which goes there. So that means the points are actually going to line up with the marks. Now the negative, since it's being reflected over the x-axis, the negative says go down first instead of up. So at the next mark, instead of going up, we would go down, then 0, then up. Working our way backwards, realizing that the curve's going to go like this, we go up, 0, and down. And we've got our important points. Then it's just our goal or our desire to make a nice sinusoidal curve that looks something like that. And so that would be the answer for number 9. Number 10 is the problem y equals 3 secant of 2x plus pi over 3. And this is a very good, just culminating problem. Okay, these are the things that I'm seeing. My amplitude is going to change. I'm not going to reflect it over the x-axis because this is positive. My period will change because I have a value right here. I'm going to shift either left or right because of this. And secant is one of those, looks like parabolas going up and down every other one, so on and so forth. We're going to have asymptotes, but perhaps more importantly, I'm concerned with the cosine function because the reciprocal of secant is cosine. So with that in mind, we do know that the amplitude is the absolute value of 3, or 3. The period will be 2 pi over 2, or pi. The phase shift will equal negative pi over 3, because we need the negative there, all over the 2, which equals negative pi over 6. And so that's not going to be so nice, but we'll deal with that as our last sort of thing that we have to deal with. Okay, so my amplitude says I'm going to go up by 3 and down by 3. I'm going to make 4 marks on the positive end to represent my entire period. The period is pi. So this becomes pi over 2. The phase shift says go to the right, pi over 6. Well, pi over 6 isn't quite so easy to figure out. Pi over 6 would be 1/3 of the way from 0 to pi over 2, or 2/3 of the way from 0 to pi over 4. Now this is the mark, but we have to realize we're talking cosine, because secant is the reciprocal of cosine. And since there's no negative, there's no need to reflect it over the x-axis, so normally we start at the upper end. And so we'd get that point there. Now realize we're dealing 2/3 through each mark. So 2/3 of the way here would go to 0. 2/3 would go to the minimum. 2/3 would come back to 0, and 2/3 would go up to the maximum again. Then going this way, 2/3 here would be back to 0, and 2/3 would be at the minimum. Now this would be the cosine, but we couldn't care less about the cosine. We want to know secant. So we have to remember asymptotes wherever it hits the 0 line. So the first thing I need to do is graph all of the asymptotes. And then from here, from each of these points, I'm going to get what, may appear to be parabolas. And due to running out of room, it's very difficult, but basically we're going to get something that's going to look like this. Every other cycle or every other period has one going either down or up. And we need to remember it cannot cross the asymptotes, and we've got the minimum values right at those points.